Thank you for having me here. I'm Zhukovich, an Android developer at Just Eat Takeaway. We are a food delivery company. We have many offices around the world. But right now, I want to speak about UI testing. How can we create a really robust UI testing, which can be stable and fast? So let's start. Let's start from the very beginning. And very often we have pretty small product. And when we have pretty small product, we don't really need UI test very often because we can usually manually spend 10-15 minutes for checking our application, and this will be fine. But later on, we will have more and more feature. And of course, in this case, we need more people to test it, more time. We need to spend more time for testing, or we can think about automation. And when we start thinking about automation, we can find that we have many different type of tests. And first of all, it can be non-UI testing. Very often it's when we test business logic, we have UI testing, we have stress testing, and Monkey Runner is pretty popular in Android world for such type of test. And we have view comparison tests. So view comparison test is something different. In practice, very often we do screenshots and compare them. Sometimes it's screenshot for the whole screen, sometimes for the small part of UI. And if you want to play with this type of test, you really need to have a lot of scripts which really help you to migrate from one device to another. Because usual life cycle of any device is around 2 years. So one day you need to migrate all your tests. And when you have a lot of scripts or maybe few scripts which allow you easily migrate from one device to another, it's already pretty good. If you don't have it, it will be a lot of manual work, and of course it will be pretty complicated. And right now I want to speak about in general which type of test it's most popular and we can do for Android. And here we have local and instrumentation tests. And both local and instrumentation tests can be UI and non-UI. We can do a UI test for a local test with a Roboelectric. However, it have a lot of limitations. And we can do proper UI test, and when we can test everything as instrumentation tests. And the main difference between local and instrumentation tests is that instrumentation tests require real device or emulator. So first of all, we mostly will speak today about instrumentation tests. And when we try to install instrumentation test from our IDE or using ADB command, under the hood, two applications will be installed on device. It will be our developer application, so our debug version of our app, and our test application. And on device, we are already together with Android, we have instrumentation API, and with this API, our both application can communicate with each other, and in this way, test application, test developer application. And today I will talk and show many examples based on this application. This application I created for UI testing workshops, for learning UI testing, and it's open source. You can find it, you can play, and a lot of tests fail on this app, and you can fix it and learn a lot about UI testing. So the first idea which we can have in mind when we think about UI testing is record and replay testing. When we just record our test, and after it we can just run them. And two most popular tools for this type of test, it's Espresso Test Recorder and Appium Recorder. So Espresso Test Recorder will generate Espresso tests, and Appium Test Recorder will generate tests with Appium. So let's try to check how they differ and what's the main difference and which code will be generated from these tools. And the first one is Appium Recorder. And if you try to read this test, it's pretty clear. You find email input, enter your email, password, press login, and later and press profile, more options, and log out. But you should spend some time and you should concentrate for reading. And it's not really easy to read. And if we try to check Espresso Test Recorder, we can see the situation even worse. because here we have some strange indexes like 0, 2, 4. So of course it's possible to understand it, but it's super complicated. And if we try to compare in default formatting style, which Espresso test recorder generate code for us, and we try to rewrite this code to Espresso, we can do it much simpler and it will be much more readable. And as you can see, first of all, these tools generate super unreadable code. And let's try to analyze other issues which we have with this type of tests. And first of all, it's if we change the app, if we change even small part of the app, most probably we should rewrite a lot of tests. And when I should rewrite, if we use record and replay approach, we should re-record a lot of tests. So it will be super time consuming. The next problem which we can have is network speed, because many frameworks usually have some timeout for which they wait. And if your network speed will be super slow, you can have just errors and flaky tests, which already not good. With Espresso, most probably, I checked it in last version of Espresso Test Recorder and Stable Android Studio. We can have a situation when our code just wouldn't work if we send any requests and wait for data. Because when you record it for Espresso, it's not delay, but in practice, when you run it, it just wouldn't work. So in worst case scenario, it's just your recorded test wouldn't work if you should wait some time for any data. In other cases, it can work, but it will be super unreadable. And the next problem is test data, because when you want to have a scenario and you want to use it in real backend, and you will try to create account, and when you record test, you enter your email address to the input field on device. But the main problem is that when you try to run this test multiple times, you cannot create multiple the same account. So if you really want to customize it, you should do it manually, and with some tools it's just impossible. So it's also a problem. And of course, unreadability. It means that we should think more about different type of UI test, because record and replay test, it's not really working for Android. And the first point is tools which help us to find elements on the screen. And here we have two different tools which are available. The first one, UI Automator Viewer, available as part of Android SDK, and another one is Layout Inspector, available as part of Android Studio. So the main difference between these two tools is that UI Automator Viewer can analyze any application installed on device or emulator, and it doesn't matter if your device or emulator have root permission. However, it provides not a lot of information about these views. However, Layout Inspector can analyze and provide much more data, but this tool can analyze only the debug version of applications, or it can analyze any application if this application has, if your device or emulator have root permission. So it's already pretty complicated. Very often, any of these two is enough, because it's provide very often enough information for testing. But if you really want to use, as example, color of some text field in your UI test, UI Automator Viewer wouldn't be enough for you. So, and let's try to write the first test case with Espresso framework. So, as you can see, Espresso framework has just a few methods from the very beginning. It's on view, and inside on view we try to find our view, and after it we try to perform any actions like replace text, click, or just check that some view is displayed or text is correct, or we can create our own actions and matchers for checking state of the view. And in this case is understandable and readable, but this scenario is a bit worse, because here we try to do simple navigation between two screens. And first of all, we enter email, password, and click to the login button. But the next step is to wait some time until we send request to the server and get response from the server. So we need to wait. For Espresso, inside Espresso, we have idle resource mechanism, which allow us to do it. So the next situation, what we need to do, we can just check amount of items in our recycler view and continue with all operations. But if you don't see a screenshots, it's pretty complicated to know which actions we try to do in different screens. So it's not really readable. We can try to make it a bit more readable, adding some comments, but in pretty big test, we'll have a lot of comments and still it will be pretty long test. And starting from this moment, we should first of all try to make it more readable. And one of approaches to add readability to our UI tests is to create domain-specific language DSL, or very often it's also called like small framework for testing, because here terminology between QA engineers and developers are different. So let's take a look at super simple scenario. It's end-to-end scenario. When we start from the login screen, we log into the application. Later on, we move to profile screen, check email and name. And the final step, we log out from our application and we will see our login screen again. So let's try to make our small DSL which improve readability for our login operation. Right now you can see code with Espresso when we have on view and performs. So the first step I propose to do is to create our basic operation area. And in this approach, I will use robot pattern, which is pretty familiar in Android, but under the hood, it's just page object pattern, which used in many technologies for almost any UI automation. So here we will try to some generic abstraction in our base test robot. And here we will have functions for enter text and click on view. I propose to make it super generic in this case, and after it we can use it in our next robot. And in this case, we can create a login function which will use enter text for enter email and password, and click for press login button or do any other operation which is needed. The final step is to add a bit syntactic sugar, make it more readable. We can create our login screen function, which as an argument has a function from our login screen robot, and after it we can see pretty readable. We can see pretty readable scenario. But here we should think more about abstraction or level of abstraction of our framework, because this test case, this is two similar versions of DSL. One has a bit more granularity and a bit more detailed operation, and otherwise is more generic one. So we can do login with two different ways. First of all, we can use enter email, enter password, and press login, or just have one function. So if you want to do only end-to-end testing, a login function will be enough. But if you want to do another type of testing, it can be not enough, because let's try to think about scenario when we enter our email address and after it we try to check our error. So in this case, we don't really need to enter password and press login, because it's just wasting time for our scenario. So in this case, it really depends which type of tests do you want to use. And if we really want to create a small DSL which will be super easy to migrate to something new, as example, replace Espresso to Appium or to any other framework, I propose to follow this approach, because under the hood we will have base operations abstraction, and only base operation abstraction will really know about your framework like Espresso. And after it, screen will use only methods from base operation. And of course, test case will use method from the screen robot. And in this case, if you want to replace one framework to another framework, you need only update base operation layer, and all other layer will look like similar. And you don't need to spend a lot of time to update any layers. So Of course, building such even simple framework for more or less big application, it can be pretty complicated, especially for the first time. And of course, these approaches provide readability and reusability, but it's also pretty complex to build, especially to build something really great from the first time. And this many layers of this approach are framework independent because our test layer and our screen layer will be framework independent. However, yes, all our basic operations will be framework dependent. And right now, we already improve our readability. And the next thing which we can try to do is make our test more efficient and faster. So let's come back to our application. And as you can see that all screen in this application has access to internet and require internet connection. So it means that we need to wait when we switch from one screen to another. We need to wait when we open screen because we want to get some data. And we also should remember to clear data after every test, because as example, even during logout, first of all, we remove session from the backend, and after it, we should clear our information about session inside our database. So in practice, we should remove, we should think about a lot of stuff about cleaning our application after login, about cleaning, about sending also request and waiting for it. And here, when we want to test this application, we have few approaches. And the first approach is to use real backend. And in this case, of course, it wouldn't be super fast because we need to use real backend. One of the options as alternatives is to try to replace our real backend to our debug backend or fake backend. It will be much stable, but we need to synchronize responses, because when real backend is changing, our debug version of backend also should be updated and also should send the last responses. And other approach, we can use make mock or fake data. First of all, we can use mock or fake responses from the server, or we can use mock or fake layers of our applications. Of course, if it's available and if our application allowed to do it. So let's try to compare different approaches which we can use for UI testing. And the first approach, I think it's super popular because it doesn't matter about architecture of application, about how well your application really created, how testable your application for UI test, and it's end-to-end test. So the main idea of end-to-end test, it's check entire the product. Very often we start from the splash screen and we navigate between different screens. And of course, sometimes we spend a lot of time for navigation, because very often when you want to check something, it wouldn't be on the 7th or 8th screen. So you really will spend a lot of time for navigation between different screens. Most probably you will interact with real backend. And as I told, entry point of application will be main screen of your application. And functional or unit UI tests, because in many different sources you can find different names for this type of UI tests. And here entry point can be any screen of application if your framework allows to do it, because with Appium it can be super complicated. With Espresso it can be it's easy to do. The next thing is interaction with server, and here we can use real web server, we can use debug server, we can mock responses, or we can mock anything. So in this case, it's super flexible. In this type of test, usually we really don't need any navigation, or sometimes we need only navigation between neighbor screens. It means that we don't lose any time for navigation. And the main idea of this test, it's mostly UI verification, how our UI will react on different data. And if you try to compare time execution of these tests in average, of course, for UI tests, it will be from 2 to 15 seconds. For functional tests, usually it can be less than a second. So functional tests much faster than UI tests. And of course, you can write a lot of functional tests because they are pretty fast comparing with end-to-end tests. And here we should speak a bit more about different frameworks which we have in Android world. And the three pretty big framework which have a lot of different flavors. It's Espresso, UI Automator, and Appium. So Espresso and UI Automator, it's native framework, and Appium, it's a framework which allows us to write one test for different platforms. So speaking about Espresso, it's pretty readable, especially for the small tests. And in addition to it, it has synchronization between when we switching activities and fragments. People who tried to play probably many years ago with Robotium remember that Robotium haven't any synchronization, and we manually added some sleeps or other workaround just to wait some time until the screen appear. And of course, it's added flakiness. Espresso have it under the hood. When we need to wait, Espresso have few different mechanisms for waiting. It's different type of idling resources. And with Espresso, we can run any activity from the application. So speaking about UI Automator, UI Automator can interact with operation system. You can open any application, and this framework will be super helpful when you want to open your messenger and click to the link, and this link open your application. Because this approach is possible with UI Automator, because this framework is allow us to test everything what you have on device. Because Espresso allow you to test only your developing application. So in this case, we can have much wider area what we want to test. We can also press button lock and unlock device. We have access to notification and permission dialog with UI Automator. And Appium under the hood use Espresso and UI Automator. So it means that it's more combined approach. And Appium has many features from Espresso and many features from UI Automator. However, we can manually inside even one test combine Espresso and UI Automator without any issues. So let's try to compare these different frameworks and try to understand which framework is better, or maybe it's faster. Of course, it really depends what you really want to achieve, but let's try to compare them. So Espresso has access to Android resources, and by Android resources, I mean different translations which you store in your XML file, most probably. And it also have access to drawable to layouts, etc. The most important thing here is translations for different languages. The next super important thing is type of test, because UI Automator and Appium are using black box approach when this framework don't know what we have inside, and we know only input and required output. And Espresso, it's more about gray box testing. And when we have access to internals of the application, and in this case, it's resources from our app. And the super important part, it's time execution. And if you compare all this framework, Espresso is super fast comparing with all other framework. All this type of I rewrote as one pretty small suite of tests with 3 different frameworks. So this time, it's of course average time, but this suite test the same stuff. So as you can see, Espresso is much faster, and with Espresso it was less than a second. With UI Automator it was almost 9 seconds, and with Appium it's more than 12 seconds. So as you can see, if time execution is super important, the best choice is Espresso. In addition to it, Espresso provides a lot of flexibility. However, we have a lot of flavors of espresso. And here we have many different frameworks with own features. And the first framework is Barista. And Barista allows you to interact with your application. It based on Espresso. In addition to it, it have really cool rules which you can use in your tests. It's rules for clear shared preferences, database files, which can be created during your tests. And in addition to it, it's try to solve problem with flakiness. It has two additional annotations which can be applied for the test case. It's allow flaky and repeat with amount of attempts. So if we use repeat annotations with 5 times, our test will be executed 5 times, and it will be green only when all 5 times everything work perfectly. Allow flaky allow us to have failings, allow us to have a situation when test will fail, as example, 4 times, and 1 time it will pass, and it means that test is working. It just helps you to handle flakiness, but of course much better to investigate reason of flakiness and try to improve it. This is example of test case with Barista, and I will have similar example but with different frameworks. So as you can see, it's pretty, we should write a lot of code. If you want to make it readable, we should create our own abstraction. Comparing it with Kakao, which already provide abstraction, it will be a lot of additional work. And one really cool feature of Kakao is interceptors. So interceptors, it's something between our Espresso framework and Kakao abstractions. And we can create or reuse interceptors which can rerun pretty small functionality. As example, when you try to click on button and you cannot to do it, you can wait pretty short period of time and click it again. So you can create many different interceptors which allow us to fight with flakiness. Especially it was helpful a few years ago when emulator was much worse than right now. And we have Kaspresso framework, and Kaspresso framework is based on Kakao framework. So it's get DSL from Kakao framework, but in addition to it, it also includes include K-Automator. It's improved version of UI Automator, because in UI Automator you can find different elements. You will have a delay for 500 milliseconds. In K-Automator, this delay is reduced for 250 milliseconds. So your test just will be faster. And it also have additional DSL for operations before and after test. It can interact with device because of K-Automator. And it have really advanced report system which allows you to generate pretty beautiful reports. So, and here you can see that in addition to our DSL, we have a few more functions like before test, after test, and run, which allow us to prepare all environment in pretty clear way. So if we want to speak about efficiency and we work with database, with web service, we can, if we really want to test our application pretty fast, we can pre-populate database. Because if we think about to-do list application, and when we try to add every item manually, we will spend a lot of time. But when we will pre-populate database, it will be much faster. In some cases it's needed, in other maybe it's not super needed. If you want to mock responses from the web service, we can use different tools like WireMock, RESTMock, and mock web service. And in addition to it, we can mock or fake some layers of our applications, and this way speed up your test a lot. And the next important thing about UI test, it's especially with Espresso, is navigation between. From the very beginning, every screen was separate activity. After it, we had one activity at multiple fragments. In some project, we have multiple activities and multiple fragments. Sorry. So in this case, we can test both of these approaches. And as example for testing activity, we can use activity scenario. An activity scenario, I can just launch any activity from our application. And for the fragment, we can use a launch fragment in container. And in this case, we can test fragments in isolation. So it also can improve your testing because you can check any component in isolation. Previously, before a launch activity in fragments was added to our extensions library, we need to create an activity, and usually it was empty activity, and we added fragments to this empty activity. So launch fragment in container method do absolutely the same. Empty activity created, and our fragments which we want to test added to this activity. And of course, if we really want to test efficiently, we need to combine both approaches. I mean, end-to-end tests and functional tests. And the main reason why do we need to combine them? It's because when you use only functional tests and your functional test based on mocks, one day your backend can be changed, but in practice, you didn't update your debug server or you didn't update your responses. And if you will have only functional tests, it will work fine. Everything is good. But if you will have end-to-end test, you will find that, yeah, it's a problem. We should do something with it. So in this case, I propose to have a lot of functional tests and not so many end-to-end tests. It still will be pretty fast because a lot of functional tests will be pretty fast, and few end-to-end tests, of course, will be slow, but they can check whole application. So in Android, we also can create a shared test, which can be run as local as an instrumentation test. And in this case, we can create a shared test folder, and test from this folder can be executed as local and as instrumentation test. So for achieving it, we need to just update our Gradle file and add a common folder. And from shared test, file can be executed as different type of test. In this approach, we can create a place when we can put a lot of test data, and both test data will be available for local and instrumentation tests. It means that if Roboelectric is enough for a lot of your cases, you can run your espresso test as local test and as instrumentation test. Because the main and really cool thing about instrumentation test that you still can run you can run UI tests on different devices simultaneously, and we still have fragmentation, and still it can work on some devices. So if we have its UI test, we can run it on different devices. But if, as example, after any commit, we can run them as local test, and it also will be fine. And very often UI test doesn't add it from the very beginning. Very often we add such type of test when our project already exists. And I propose the next way how we can add such test and which cases should be covered first. And first of all, it's application flow. So navigation and checking between switching between different screens, it always should work perfectly. The next thing is priority. Of course, every screen has different priority. And one of such differences is login screen and, as example, settings screen, which is not super popular. The same with about screen, license screen, etc. So always login and payment screen are super important for any product. And probably this is the first screen which should be covered very well. And the last part is analytical data, which can be super helpful for developers and QA engineers. And if we have few different options and we can see that our users use one option much more than other one, the most popular options should be covered much better because much more user use it. And I want to speak a bit about flaky tests, because flaky test is super important and pretty complicated topic. And the first thing which we should understand, it's reason why our test can be flaky. First of all, it's testing approaches, and of course, end-to-end test can be much more flaky than functional test. First of all, because they're longer. First of all, they depends on real backend, and we can have different overloading, or we can have different situation. Our network speed also can be different when we try to communicate with our real backend. The next approach is tools which we use, and first of such tools, first of all, it can be emulator. Other approach which really depends on the tool is test framework, because test framework work really differently. After it, it's parallel execution. So if all your tests communicate with the same backend, one account can, one device can, test case on one device can create account, and test case on other device can remove the same account at the same time. And of course, it will generate a lot of flakiness. And the last part is test data. If you always try to create the same account and test case which just remove your account just fail, it means your account still exists. And in this case, it also can be a reason for flakiness. And we can find and handle with flaky test with different approaches and different tools. And the first of such tools is continuous integration. So let's imagine that we run all our tests and we have situations that 4 of our tests is flaky. It's not flaky, they just fail it. So we can rerun this test for a few times. And after it, we can see that only 2 tests really failing, and two of them already passed. So it means this was red and right now a green, they are flaky test, and we should think how we can fix it, how we can avoid flakiness. And for other approach to failing test, we should really think about real problem of such tests and such scenarios which is covered. And the other approach which help us to fight with flaky test is, first of all, Android test orchestrator, which can clean up everything connected with permissions after or before your test case. We can create rules which will clear shared preferences, databases, and much more. We also can use interceptors if we use such framework, or we can add interceptor approach to our domain-specific language if we use it. And some framework use functions like use annotations like allow flaky, or you can create your own for your own environment. First of all, thank you for your time. This is all from my side. I really encourage you to explore more about UI test, about your day-to-day tools, about your frameworks, because I saw many situations when people try to solve problem which already solved in a framework because they didn't explore it enough. So I really recommend explore a lot of tools, especially tools which you use for day-to-day. If you have questions, I always happy to ask and happy to talk in my Twitter. I encourage you to check my blog, and let's right now check questions which we have in Slido.
Great, Alec. Thanks so much. Uli's going to get that pulled up. We do have a number of questions that have come in, so I think it's going to be a good Q&A session. We're looking forward to it. There we go. I'll let you take it away.
Yes, cool. The first question, I tried setting up test robots for our project, but setting up mock service responses from the UI test class itself seemed a nightmare. How do you do it? So it really depends on which approach you want to use, because if you can use you can emulate responses with mock web service tool, or you can replace one of layers in your application. As example, you can mock responses from your repository. And in this case, it's two fully different approach. And in this case, it will work. It will work differently. I created small examples. A small example you can find in my GitHub. It's called map nodes. And in this case, I created one more robot. We just allow you to mock. So if you are interested, please send me a message in Twitter, and I'll just share this example, and we'll be happy to discuss more, because it really depends which approach you choose for mocking. So yes, what are your thoughts on using idling resources? According to Google, they should be added to your production code, which I think is the worst idea ever. First of all, we have different types of idling resources. First of all, we can create our own idling resource, or we can use count idling resource. So if we want to use count idling resource, yes, we need to integrate it into our application. However, with our own idling resource, we can, as example, create idling resource which will check that our loading indicator is displayed on the screen. So, and our test will wait until our, as example, progress bar will be displayed on the screen. In this case, it shouldn't be integrated into your application. However, from my perspective, the biggest issue of idling resource is that by default, when you create your own idling resource, of course, it will run in a loop, and it will it will check your requirement once and few times, and by default it's 5 seconds. And it can be super tricky when you try to test message on a snack bar, because it just can disappear during these 5 seconds. So in this case, the simplest approach which you can use, you can create pretty small and super simple function using UI Automator, because test can be, we can use Espresso and UI Automator in one test. And with UI Automator, this delay time is 500 milliseconds. So you can recheck for your requirement every 500 milliseconds, and it will be much faster than with idling resources. However, if you will check idling resources policy, if I remember correctly the name, you can reduce timeout for idling resources. And for me, usually the proper timeout is 1 second, but 1 second it's still much slower than you can achieve with UI Automator. If you try to use K Automator, it will be even faster, because this delay even smaller in this framework. Yes, the next question, how does one UI test animated element? As we hopefully all UI animations should be never enabled on emulators for UI tests. In practice, I never saw good tests with which check animations, but in practice, it also really depends on the framework. If you use UI Automator, it's not problem at all. You can have UI turn off your animations, but the main problem is that it can be a bit flaky because of these animations. Because when you have animations, one of your UI element can appear on the screen and other just can be hidden. If you want to have animation enabled, you should think a lot for which element you're really waiting, because many UI frameworks, when they check visibility, they only check visible or not, visible, invisible, or gone. But in practice, when you have animation, this situation much more complicated. So I never saw really good solution for testing animations. But if you can use UI Automator or IPOman, it will work pretty fine. I never understood why one would you put UI test in test folder? So first of all, it really depends on which type of test you really want to test. I think much better if you want to have possibility to run your UI tests as local test and as instrumentation tests. What you can do is to create shared test. It's shared UI test, because otherwise, very often it's not so clear when your tests like UI tests, or it's when just unit tests which you have in test folder. I propose to put a lot of UI tests in shared folder. It can be shared test or it can be shared UI test. It can be done with similar approach. If you try to Google, you can find my articles which I posted around 2 years ago how to create such folder. So in practice, I propose to create a shared test and put all your UI tests to this folder, or create shared UI test folder and test which will be available for different frameworks. Otherwise, you will have duplications. Hello, sorry, I couldn't stay to finish the talk, but I saw you a few weeks ago on Dutch Android user group. I wanted to ask something. I checked your GitHub for the barista app. Yeah. Okay, and the next question I continue below. But I got on something. My UI test fail in case where I open a detail of a list and I press a button. So maybe will be much more simpler if you create an issue on GitHub, and I'll try to help you with this situation, because it can be complicated. Yes, the main idea, because I'll try to answer this question because it's pretty interesting. Because when you try to test something, your components can be visible or invisible on different devices, because your device can be bigger, can be larger or smaller. So in this case, inside action, you have scroll to action, and this scroll to action allows you scroll to require elements if your screen is scrollable, and it will work with recycler view or with scroll view. So please create an issue and I'll try to help you. Yes, but yes, okay. Questions. In your barista example, it's look like you test the activity instead of individual fragments. Why not focus on individual fragments testing? If I remember correctly, barista application, it's every screen is activity. So if every screen is activity, in this case, yeah, you can just test every activity. If you have every screen is fragment, or you want to test fragment in isolation, you can test fragments. And I'll take a look at my example and update it. Thank you for your comment. Any thought of keeping emulator stable on CI, like avoiding a system UI isn't responses dialog, for example? I never had such issue with emulator. It's also really can depends what you try to test, and I cannot say anything unfortunately about it because I never had this issue. But yeah, I assume it can happen. A recommendation for logging a failed test on continuous integration, including log catalogs plus screenshots. Yes, I think the screenshot is one of the best option. Or in addition to it, a really good option is record the video and compress them. And in this case, if you will record the video for each test case, later on you can remove video for all past test cases and store only failing test cases. If you use Firebase Test Lab, you already will have recorded videos. So I think a video or screenshot, it's really good option, because with Espresso you can add additional environment which will take a screenshot when your test fail. So it's possible to do. Many frameworks already do it, and it's really good. It's really good approach to understand what's the main problem. So the next question: which part do you think should be mocked in the functional test? Is it API response or presenter view model? It really depends. It really depends on what you want to test. Because if you want to check only UI and how UI represent, you can even mock a presenter or view model. But if you want to check a bit more, as example, how your repository work, how maybe your use cases work, of course, it really depends on the implementation, and presenter in view model. In this case, much better to mock response from the API. So in this case, you should really understand what you try to test. Of course, if you will mock a view model, it will be much faster. In this situation, I really recommend to cover all main scenarios, success and some failures, example login, with end-to-end test. And when you try to create this combination, you can even mock your repositories, because in many other cases, you will use real backend, and with real backend, it will be checked. So it also depends what you try to test. Maybe this will be answered in your presentation. Do you have a good way of sharing tests across numerous emulators and devices? Unfortunately, if I remember the tool called Spoon, in addition to it, if you use Firebase Test Lab, you can use Flunk. It just shared your test into different devices. Both of these tools are open source, so if I remember correctly, it's called Spoon, but I think if you try to Google it, you find. If not, please send me a message and I'll share this tool with you. In our team, we do a lot of setup regarding mocking service, currently using extension functions on the service repository. Do you have a better idea for this? In this case, I really propose to have a lot of such functions in one place, because you can reuse them. I also show it in a map notes application, which is available on my GitHub. In this case, I created prepare robot, and in this case, it was like mock authentication request, and after it, for your application, it means that you already are logged in your application. Any tips for implementing idling resources for fully React RX-based state machine? So idling resources, because from my perspective, good idling resources shouldn't be connected with your implementation. Good idling resource, because if you use counting idling resource, it should be added to the code, and your code will be updated for your test. I think it's pretty bad approach. So I propose to, as example, if possible, if you have any indication of loading, check this indication. Check if it's visible or not. If it's still visible, it means you're loading. If it's not visible, it means you can continue with all other actions and checks. Which framework or tool would you recommend for functional test? We use Cucumber plus Appium. Wanted to know if there is anything better for Android. I really recommend Android. Sorry. I really recommend Espresso. It will be super fast. It can be super flexible. However, to be honest, if we think about flavor of espresso, I really recommend Caspresso framework. It's have a lot of functionalities, and it has a lot of additional features, like you can still use idling resources and everything from native Espresso. In addition to it, you can use anything from Cacao framework, and In addition to it, you can use Kaspresso features and K-Automator, which will find elements much faster. And in practice, when you try to use API of Kaspresso, it's you don't really know that for some waiting operations you use idling resources or K-Automator. So I really recommend Espresso. It can be not so easy because it requires a lot, some additional work. But if you compare execution time, it will be much faster with than with Appium. Yeah, I think this is all questions. Yes, thank you. Thank you for joining. Thank you for answering questions. And I hope you learned something new today.